Tianjin, China. The fourth largest city in China is home to more than 15 million people and the 10th largest seaport in the world. This technologically advanced city is also home to one of the most automated biosolid composting facilities in the world, designed, built, and equipped by BacTee Systems and BDP. The Zhenghui Wang wastewater treatment plant, located in Tianjin and completed in 2012, produces 300 metric tons per day of treated sewage sludge or biosolids. Local officials sought an environmentally sound, safe solution for treatment and reuse of the biosolids. In 2013, the biosolid compost facility commenced operations adjacent to the wastewater treatment plant. The compost facility has won numerous awards. The plant is completely automated, with most material movement done by conveyors or pumps. The entire facility is monitored and controlled by a BacTee Comp-Air control system that monitors key process perimeters and adjusts corresponding process equipment accordingly. The BDP ICS composting process occurs in 20 280-foot long by 10-foot wide open top tunnels or bays. The bays are automatically loaded by telescoping overhead conveyor. The bays are negatively aerated through BacTee's patented floor system, with all foul air removed to a BacTee biofilter odor control system for treatment. Once the bays are loaded, BDP's fully automated agitator processes the bays simultaneously, turning, shredding, and moving the compost material down the length of the bay. After approximately 20 days in the bays, the material is discharged from the bays by the agitator onto a conveyor. The finished dry composted material is then belt conveyed to a screening device. The larger fraction is recycled via conveyor back to the front of the facility as an alternate amendment, and the finer fraction is bagged or sold in bulk for landscaping and agricultural uses. The first step in the compost facility process is the materials receiving and mixing system. Here is where the three feedstock components, fresh amendment delivered by truck, recycled overs delivered by conveyor, and the biosolids pumped from the wastewater treatment plant are blended in correct proportion for the compost feedstock material. This system includes hoppers for biosolids, overs, and fresh amendment. These feedstock materials are belt conveyed to the mixer. The biosolids, overs, and amendment materials stored in the bins are deposited onto a belt conveyor based on the preset ratio for delivery to the mixer. A variable speed screw conveyor at the bottom of each hopper meters out the correct amount of each material as directed by the process control system. The target is to have a feedstock mixture of approximately 40% dry solids. The feedstock material exiting the mixer is belt conveyed onto the bay loading conveyor that spans the width of the facility across all 20 bays. The bay loading conveyor includes 20 plows that are lowered automatically as directed by the process control system. These plows direct the feedstock material into the selected bay. A traveling telescoping conveyor is used to evenly distribute the feedstock material over the front 18 feet of the bay. All of the material movement is done automatically by the control system. Each bay can accept up to 40 cubic yards of feedstock material, referred to as a charge. Bay loading is determined by a preset runtime sequence for the telescoping conveyor. BacTee's patented negative aeration system is utilized in the compost bays to ensure appropriate aerobic conditions are maintained in the compost material, as well as for maintaining appropriate temperatures. Each bay has aeration zones, and each bay group has corresponding dedicated aeration blowers. The BacTee floor system includes a series of cross arms for uniform suction of process air across the bay group. The BacTee floor is designed to ensure uniform suction of the process air along the bottom of the compost pile. The aeration blowers draw the air down through the composting piles and exhaust it to the biofilter. RTD-type temperature probes located in the aeration blower suction piping provide real-time temperatures to the process control system, which uses it to modulate blower speed accordingly. Fully automated BDP agitators and dollies are used to process the bays. The dolly moves the agitator from bay to bay. The rotating drum on the agitator breaks down larger material and throws it onto the conveyor, which deposits the material about 13 feet behind the agitator, thus creating space at the front of the bay for the next charge of material. With each pass through the bay, the compost material is moved down the length of the bay, remixed, and porosity is reestablished, ensuring optimal composting conditions. After around 20 days of composting, at the discharge end of the bays, the agitator deposits the dry compost onto a submerged conveyor for removal to the screening system. Compost discharged from the bay is belt conveyed to the 3/8 inch trommel type screen. The overs, material over 3/8, from the screening process are recycled back to the receiving system for further composting. The fines, material under 3/8, are the high-value compost product and enter the product packaging and storage area. There are 6 fiberglass reinforced ducts connected to fans or blowers in the compost facility. The outermost bring fresh air from the fans into the building. The middle ones remove processed air via the bay aeration blowers from the bays and deliver it to the biofilter odor control system. The inner ducts withdraw building cavity air using the biofilter fans and also deliver it to the end of the enclosed biofilter. Most agitated bay composting facilities use positive type aeration in the bays, which disperses the foul and corrosive process air into the building, relying on the ventilation system to adequately remove it. The BDP BacTee ICS process utilizes negative aeration technology, directly drawing the process air down into a ductwork network that delivers it to the biofilter odor control system. This approach allows for maximum capture of the most odorous gases in the process. It also results in a much improved working environment in the building and greatly reduces corrosion attack within the building. All negative aeration blowers and ductwork are properly designed for the high corrosion potential. By having all key process components automated and managed by one central control system, it allows for not only minimizing operations staff, but also the optimization of the process. One example of this is BacTee's targeted ventilation system. The agitator position in the bay is monitored by the control system. When the agitator is moving under a specific ventilation duct, the control system is programmed to ramp up the fan speed associated with the duct to maximize capture of the vapor. The negative aeration process captures the major heat potential from the process. If desired, the hot process gases can be passed through a heat exchanger to preheat building makeup air or to heat water for the other process uses. We hope you found this video interesting. Contact BDP Industries for more information.